to stop, or we want to stop him.
That's the finger.
And then and push that button. And I'm having trouble with this light. I hope it keeps on. There's a switch.
You get to test the sound.
Yeah, I've already tested it.
I've already tested it, so it's working all right. Yeah. Oops, little ring there.
Right. And she looks at the monitor there.
Yeah, I noticed her name and as doing all the work in these things. In the earlier thing. Let's see, do I want that buttoned? I guess I do. I don't care.
All right, now let's see. I'll want to remove this light to make sure there's nothing on his glasses. I can just move it to the side. I think none. It's okay now, isn't it? Fine. Now, see, when you turn this way, it will, but you won't ever turn.
I shouldn't turn more than this far.
Yeah, that's right.
Mm-hmm.
So then there's nothing on the glasses.
If I can turn over this way,
then there's no problem.
Why would I? Mm-hmm. Now tell me when it hits the glasses when I come this way.
Not yet.
Not yet? Oh, well, then
I think I moved it. There.
Yeah.
There it hits.
Okay, then I don't.
Too high.
I won't need to go. I won't need to go that far anyway. Let me wipe off my glasses. I'm getting little spots from that light over there.
All right, well, you want to zoom, try to zoom and see, see how it, the other way. Yeah, I think it's going to work out. All right, I think fine. Well, and as I say, we'll just make it run as long as it's natural. The tape is 2 hours, so we'll change to 2 hours. But if it runs over that, well, we'll just
put another tape.
That's all there is to it. So.
I don't think my life lasts more than 2 hours.
All right. You ready, Jane?
Ready. Okay.
And
It's on.
It is on. All right. So good. We just cut that out. All right. Well, fine. I think we can now start. And today we have the privilege to interview Dr. W.T. Hanson, whose distinguished career in photographic research has made key contributions to the development of modern color photography and the many applications of photography to science, technology, and art. It is a pleasure to introduce Dr. Hanson. Please proceed, Dr. Hanson.
Yes, thank you. Well, I might as well start at the beginning.
Very good.
I was born in Georgia. Both parents were school teachers and lived in the country. We lived on a farm, but both my parents taught school. And as a youngster, they taught me at home. So I started school in the 3rd grade at age 7, a little bit out of my age group, and was out of my age group for about 30 years, but that didn't seem to make any difference.
Fine. What city was
Smyrna, Georgia. Smyrna, Georgia, which is about 15 miles out of Atlanta.
Yes, I know the location.
Yeah. I walked about 2 miles to school and home. I owned 10 cows as a child and milked the cows each morning before going to school and then again after coming home from school. So I had a busy life as a youngster.
Yes, that kept you out of the usual adolescent diversions.
Yeah, very much so, very much so. So I started the school in the 3rd grade. I went to summer school and skipped the 5th grade. Graduated from high school in 3 years, and at age 14 applied to college and was a little too young to get in, so I had to work for a year before going to college. Then I went to the University of Georgia at age 15. I decided I was going to be a civil engineer and studied civil engineering and physics and that sort of course to start with. And my first year at college, I took a chemistry course. And the professor must be the person that lured me into chemistry, because I was crazy about the professor and the course. So after 1 year, I changed over to chemistry as a major and graduated in 3 years with a BS degree in chemistry. At the end of that 3 years, or in the middle of that third year, which now was 1929, a Mr. Billings from the Eastman Kodak Company, who went around interviewing students at various colleges, came to the University of Georgia, and I had an interview with him. He offered me a job for the summer with the Eastman Kodak Company in Rochester, New York. So that summer, after I graduated, I went up to Kodak and had a very fine experience working there that summer.
Yeah, that must have been a real privilege meeting the famous pioneer in photography, Dr. Billings.
Well, he was not that much of a pioneer in photography. He was in the personnel part of it.
Oh, I see.
But it was Eastman was the name of the pioneer who was so important in photography at the time, and Eastman I had heard of even then, but I did not get to meet Mr. Eastman. At that time, Mr. Eastman was in his 70s, and I was a lowly student down in the laboratory, and I didn't meet him.
Oh, yeah.
And I'll say more about that a little bit later. But one of the things that I did that summer was to learn to blow glass. I made a lot of equipment out of glass in the laboratory there, and I spent practically all of my noon lunch hours blowing glass because I enjoyed it so much. So I learned a good deal about which I used a great deal in my graduate work later on.
Yes, if someone doesn't have a skill in glass blowing in chemical research, he's very severely handicapped.
He's very severely handicapped. Probably not anymore, but in those days that was the case anyway. Well, after that, I went back to Georgia for 2 years and got my master's degree in chemistry. And while there, I applied for a fellowship at 10 colleges all over the United States. I picked out the big colleges and applied to 10 of them. And this was now 1932, and I didn't get a fellowship anywhere. So I decided I would go to Berkeley because I had studied Lewis and Randall, the textbook of thermodynamics. The famous thermodynamics textbook. I knew those two names, so I went to Berkeley.
As a matter of fact, I still have, I think, my Lewis and Randall thermodynamics text published first, I believe, in 1924 or something like that.
I have mine too.
Yes.
I do too. Well, the day before I left Smyrna, Georgia, to drive with a bunch of friends out to California, I got a letter from the University of California saying that they were all full, please don't come. I put that letter in my pocket and I went right on anyway. And when I got out there, they asked me if I hadn't received that letter, and this is one time I did tell a lie, not very often, but I said, no, I hadn't received the letter. And so they said, well, since you're here, you might as well stay. So I stayed.
Well, that's a remarkable story.
It is a true story.
I should mention at this time, you are in very good company, because Linus Pauling had a similar situation, and he applied for graduate work at the University of California, and he was also turned down. So you're in very good company.
Yeah. Mm-hmm. So the first year I went to work for Randall, and I didn't get to see much of him. He was very busy writing books still, and I didn't see much of him. The second year I worked for G. and Lewis, which was very fortunate because he was a wonderful person to work with and for. And he was, of course, the dean of the college and the dean of chemistry almost at that time. But that was a very wonderful experience. And in 1934, 2 years later, I got my PhD degree. Now, at Berkeley, the graduation is held pretty early, in fact, in May. Most colleges are later than that. But my birthday is the 28th of May, and they had the graduation about the 25th or 6th, and I was still 21. So I can say that I got my PhD when I was 21 years old.
That's very remarkable. That's almost some sort of a new record for getting a PhD.
Almost. Of course, I was 22 a couple of days later, but still I was 21 when I got the degree. So I wrote to Kodak and said, I've got my PhD degree now, I'm ready to come to work. And I'd had a letter back from Kodak saying, sorry, we don't have any jobs. This was 1934.
Yes. Well, that was that time in our history where jobs for both undergraduates and graduate students were almost non-existent.
Almost non-existent. They were very hard to come by. That was the depth of the Depression. Well, I waited a week, and I wrote back to Kodak and said, I'm very anxious to work for Kodak. And they wrote back and said, we don't have any jobs. So I waited another couple of weeks, and I wrote them again. I said, I haven't applied anywhere else. I want to work for Kodak, and I certainly do want a job. Well, about a week later, I got a letter saying, come to Rochester for interview, be prepared to stay. And so I went to Rochester in July of 1934, and I've been there ever since.
Well, that's a remarkable story.
It
shows
was
that persistence.
persistence pays off. I have given advice to 2 or 3 college students that persistence pays off, and in a couple of cases it did for them too.
Oh, yeah.
So it's worthwhile sometimes anyway. I started in the photomicrography department, which was studying some miscellaneous subjects, but very shortly moved over into color photography. And that subject really attracted my attention in my life, and that's where I spent most of my life from 1935 on in color photography. Can we cut a minute? A little bit about photography as to what it's all about, or the history, how it came about.
Yes, well, that background would be very helpful.
Actually, we go all the way back to Leonardo da Vinci, who dealt with the camera obscura, which was the box for making images. So, of course, you have to start with the image, and then recording it is what photography is.
Oh, yeah.
And it was back as early as 1750 that a chemist named Schultz learned that silver salts were sensitive to light. And then a little bit later, it was found out that the light effect on the silver salt was to convert it to silver. And then every 10 or 15 years, some new knowledge about silver salts developed. Other materials are light sensitive, and in fact, the first photograph that was called a photograph was made by bitumen, made by Niepce in France, and it was an organic material that hardened by light. But still, it was very shortly after that silver salts came back into the picture, and in 1939, de Geer worked out a process using silver on a copper plate and developing it with vapors of iodine, and the daguerreotype became important. And that was really the first commercial photographic process.
Yeah. I think you may have made a typographical error. You said 1939.
Oh, I meant 1839. I certainly did. Okay, that is right. Yes.
Right. Which, of course, was a fantastic development.
That was quite a development, and that had a lot of commercial use. I mean, the daguerreotypes these days are museum pieces, but there are quite a number of them around. But that had quite a lot of commercial use.
Yes, as a matter of fact, the National Portrait Gallery has quite a fine collection of daguerreotypes.
Yes, yes. But silver salts in carriers rather than just on a metal plate. In collodion, which had to be a wet plate process, you had to sensitize the collodion with the silver salt, never let it dry. So you had to do this in a dark end of the camera and then take the picture and develop it right there. So that was bulky. Yeah. And finally, about 1870, silver halide in gelatin appeared to be a very sensible light-sensitive material. At that time, it wasn't very light-sensitive, but at least it was sensitive enough so that it began to be used. which sort of brings me to George Eastman. Yeah, George Eastman was a bank clerk in Rochester, New York. And he was interested in photography himself. And he set out to make photographic materials which he would use, and decided that he would go into the business. And so he started in a very small way, still working as a bank clerk, but trying to make photographic plates out of silver bromide coated on glass. He was quite successful in 1880. He went into business and began to sell these plates. In 1882, he began to have complaints from a lot of customers that the plates that they had weren't sensitive. And he ran thousands of experiments and couldn't find the trouble. He was buying gelatin from England, and he and a friend went to England to just find out what they could find out. And they did find that one particular batch of gelatin that they had bought was causing the trouble, and that there was something wrong with it, and it destroyed the sensitivity of the plates. He replaced every plate that anybody had ever purchased. That was the way he did business right from the beginning. He replaced every plate that had ever been purchased and established his reputation that way. In 1886, he hired a chemist to do research. It was probably very nearly the first research in industry in the United States.
Yeah,
and he retired. It was very close to the first. And he hired this chemist to work out a film base so that he wouldn't have to use glass plates, and it could use a flexible film, and it would be lighter and more convenient.
Before that time, there were no flexible films?
There had been the use of paper. It had been coated on paper.
Oh, yeah.
And then he went through a period of stripping plastic on paper, and then worked out the clear plastic that did the job. So that by 1891, when Edison invented the motion picture, Mr. Eastman had the clear film and was ready to work with Edison on motion picture film. So he was right there and started motion picture film right there as soon as Edison wanted it.
And as a matter of fact, it would have been very difficult to invent motion pictures using glass paper.
Yeah, yes, it would. Yes, it would. And Mr. Eastman asked Edison, now what size should the film be? And Mr. Edison said, about that wide.
Oh, yeah.
And that's how 35 millimeter film was invented.
That's amazing.
Yes, it is. In 1895, X-rays were observed. In 1896, Mr. Eastman had a film ready to record X-rays. I mean, that just shows how alert he was and how he was staying in touch with the scientific world and working out applications of photography for whatever there should be.
That is an amazing story in science, that this one invention and development just paved the way.
For X-ray. Absolutely, that's right. That's right. Now, another aspect of his character, the X-ray film, the motion picture film, and the film base that he had worked out was nitrate, which is very inflammable. So he immediately set out to work out a more stable, safer film base. And by 1908, he had worked out safety film. This chemist had worked out safety film. Now, he tried to get states to pass laws that they couldn't use nitrate, that they would only use the safety film. The safety film didn't have quite the quality that the nitrate did. But nobody was interested, and motion picture film was on nitrate till about 1948.
It persisted
that long.
In spite of the danger.
Yes. X-ray film was on nitrate until about 1929. There was a major fire in Cleveland of nitrate film. And after that, X-ray film was put on acetate instead of nitrate.
Oh, yeah.
Now, I'm sort of jumping ahead a little, but in 1923, the Kodak company first marketed amateur movie film in a 16 millimeter form. Now, that was on acetate film, and even when I joined the company 10, 12 years later, we were not permitted to slit any film, any nitrate to the 16 millimeter size. I mean, Mr. Eastman said there's be absolutely no inflammable nitrate film in the 16 millimeter size which goes into people's homes. So he was very safety conscious from the beginning. He was a very conscious person of people and of safety.
Well, I've never heard that story before. We all know, of course, the nitrate base, cellulose nitrate, essentially is a form of gunpowder.
Yes, yeah, that's right. That's right. Yes,
terribly
yeah.
dangerous.
Yes.
I believe that Cleveland fire killed.
I don't know the story of it, but some people were killed. Yes, yes.
So that's a very interesting story of how that developed.
Yeah.
I've never seen that before.
Yeah,
Very
yeah.
interesting.
Well, that's the sort of person that he was. Now, in 1911, he visited the chemical industry in Germany. And some of the leaders of that industry asked him, well, now, tell me about your research laboratory. And he says, oh, we do a lot of research in the plant. And they did. But these folks said, but don't you have a research laboratory that does fundamental research? And he says, well, we think what we do is fundamental research, but it's all done in the plant. Well, that got him thinking. He got to wondering about a research laboratory. And so he asked some of the people in Germany, says, if I were going to set up a research laboratory, who should I get to head it? And there was almost unanimous opinion it should be Dr. C.E. Kenneth Mies, who is in England. He was a managing director of Ratton and Wainwright. He had been an early pioneer in studying the science of photography and was a businessman and a scientist. And so Mr. Eastman went over to interview Dr. Mies. By the way, he had met Dr. Mies a few years earlier when Dr. Mies had visited the United States. But he went and asked Dr. Mies if he'd come and head a research laboratory in Rochester. And Dr. Mies said, well, he had a commitment to Ratton and Wainwright. So Mr. Eastman bought the company, Ratton and Wainwright, and Dr. Mies moved to Rochester.
That's an amazing story.
Yeah.
That in order to get the man,
he bought the company. Now, he didn't go around Mies' back to do this. I mean, Mies and he worked out this deal that he should buy the company, but he did buy the company, and Dr. Mies came to Rochester in 1912. One other thing about Mr. Eastman, I mean, he and the company is just worth knowing about. In 1918, during World War I, we had been getting a lot of chemicals, organic chemicals, not just the Kodak company, but the whole country got organic chemicals from Germany.
Oh, yeah.
And that source was cut out. So in 1917, I guess it was, Mr. Eastman set up a laboratory to manufacture organic chemicals. And Eastman Organic Chemicals are still available to colleges and people that need them today.
Oh, yes, because that's in chemical research, we always turn to Eastman Fine Chemicals for a supply of chemicals. I believe that almost every research laboratory in the country did that.
Yeah, yes. Well, that started in 1917 during the war.
That's very interesting as to the origin of that.
At the end of the war, the Eastman Kodak Company rebated to the government all of the profits that they had made out of government contracts during the war, World War I. That's another characteristic of the company.
That's a very interesting story and one which I have never heard before.
In the Second World War, V-mail was used. I'm jumping way ahead, but still, this is just part of the story. V-mail was worked out for cutting down the loads of ships. And I guess there weren't many airplanes carrying mail around in those days. And all the letters for the soldiers were microfilmed and sent on film and then reprinted at the site. This was worked out in England and then used first by the English Army and then by the American Army. But it was worked out in England, and at the end of World War II, all of the profits made out of that operation were given back to the English government.
Oh, yeah.
So it really was he was an outstanding man, and the company that he developed, you could see that I'm very enthusiastic about it.
That's a very, very interesting and valuable aspect.
Well, now, my life was built around color photography. So let's get on to color photography.
Well, fine, because that, of course, is that development is one of the most fascinating science and technological developments of our country.
It is a very interesting one and has been very successful. You might say it started back in 1861. Clerk Maxwell in England demonstrated that color pictures could be made by photographing a subject with red light and with green light and with blue light, and then projecting pictures through a red filter and a green filter and a blue filter superposed, and that those three would make a full color picture. Very soon after that, a fellow named Duhoron in France showed that you could make a color picture by superimposing, not projecting three, but by superimposing three pigments, which were yellow, magenta, and cyan. If you took a picture with blue light and then you printed it with a yellow pigment, you took a picture with green light and printed it with a magenta pigment, and took a picture with red light and printed it with cyan pigment and overlaid them, then you would have a color picture.
Yeah, that use its complement.
It's complement. The yellow, magenta, and cyan are the complementary to red, green, and blue.
Right.
Now, there wasn't any technique for doing that photographically in those days. Painting and lithographic printing used the subtractive, the yellow, magenta, and cyan paints or pigments. And for many, many years, there was a lot of printing done in three colors, but no photography. Now, the printing that was done, the inks were called red, blue, and yellow. Now, the yellow was yellow. The red was a pinkish red. They really wanted magenta, but there weren't any pigments that were magenta, and they were sort of red. And the blue, they wanted blue-green, but there weren't any pigments that were really blue-green. It was sort of blue, so they were called red, blue, and yellow. And those are the subtractive colors that most people know about. And it is those terms that I use in explaining the very important invention that I made in 1943. But I'll get to that way down the road, of course.
Yeah.
Well, anyway, so the basic principles of additive and subtractive photography were known back 1860. I keep using 1860.
Yeah. Well, that's amazing. The fundamentals were known at that early, although there was no way to take
There's
advantage.
no way to take advantage of it, and the need, the desire for color photography has been there forever. I mean, photography just happened to be black and white. I was talking with a young lady who's writing a history of color recently, and she was saying, well, the 1920s and the 1930s, the climate was right. The culture was ready for color photography. And I insisted the culture was ready 1,000 years ago for color. It's just that the technology was limiting. And this whole thing has been technology limited right up till now, almost.
Yes.
Yeah.
Incidentally, along that line, to divert just a moment, I recently saw a book with color photographs in it of the early work in Russia on color photography back, you might say, before 1920 and in the 1920s.
Mm-hmm.
Very obscure book, but very interesting.
People have been trying to work out color photography since it was in the basic ideas were there in the 1860s. People have been trying. The additive process which Maxwell demonstrated first, was worked out in practice, and by 1907 or 8, the Lumiere Kodachrome process, which was colored starch grains, red, green, and blue, were coated on the back of a plate, or on a plate. Then the emulsion was coated on that. You take a picture with that, develop it to a negative, dissolve out the negative and convert it to a positive, and project it, and through the red, green, and blue starch filters, you got the picture just of the sort that that Maxwell had illustrated. That was on the market. Now, it was very slow and not very sharp, and the colors weren't that good, but it was color photography, and it was clearly used and important.
Yes, essentially those starch grains acted as micro
light filters.
Filters.
That's right. Well, then later in the 20s, maybe the late teens in the 20s, Dufay in France came out with a method of making screens, lines of red, green, and blue filters. So Dufay color used that organized lines rather than just the random starch grains. Finley color was a different method of making the screen plates. So there were those additive color processes in commercial use starting in 1907. In 1905, Schinzel, an Austrian, who later came to Kodak for a few months in the late 30s, worked out the idea of having several layers of sensitive emulsion, a red, green, and a blue sensitive emulsion, on top of each other on the same film base. And that idea wasn't practical at the time. Then in 1912, Fischer in Germany had the idea of using color development reaction. There are certain developers that develop the silver halide to silver that will react with a coupler to form a dye. And he was able to find couplers that would give a yellow, a magenta, and a cyan dye. So he worked out the color developing process for making color pictures, but he had no way of putting the color in one layer, the other color in the other layer, and the other color in the other layer. So he wasn't successful in doing the job. This was 1912. Well, now at 1912, when Dr. Mies came to the Kodak Research Laboratories, he knew that color photography was really the objective of photography. And the whole laboratory, though it wasn't devoted to that, any idea that came along that might be useful to develop a color process was investigated pretty thoroughly. And there were 2 or 3 processes that almost made it during the teens. Dr. Kelmus of Technicolor in the late teens set out to make color motion pictures. And I'm not going to go through the details of his process, but he started, as most everybody did, with an additive process. And if you don't get the pictures properly superimposed, you have bad color fringes. He immediately found that and set out to make subtractive processes. He did work out a subtractive process, and they made 2 or 3, Technicolor made a couple of pictures during the 20s, 2-color. Now you can take some shortcuts and make a 2-color process, which gives some colors pretty good. It won't reproduce all colors, but it's a color picture that's a color picture anyway. They made a couple of color movies, 2-color, but kept working on a 3-color process. And 1932, I'm sort of tracing them all the way up. 1932, they came out with their first 3-color movie, which really was.
Those movie films that were made in color before that essentially were 2-color.
Were 2-color before that, yes. By 1928, Kodak had gotten patents from others and had worked out a motion picture film that was 3-color, the lenticular film. Now that again was additive, without fringes, and a very unusual method of making color. The film base was lenticulated, so there were lenticular lenses. And there were stripes of filters, a red filter, a green filter, and a blue filter on the lens. And those three colors would be focused by the lenticular lenses into the film. And that was developed to a negative, the silver taken out and reverted to a positive, and projected back through the filters, and you got a very good color picture that way. It was a very slow, it took a lot of light because the filters absorbed a lot. Took a lot of light in the projector because the filters absorbed it going back. But anyway, Kodak put that on the market in 1928. So that was the beginning of color film for Kodak. But now, let's go back a little bit, because the real color photography came along and was developed by a couple of musicians named Manis and Godowsky. And their story is really something. And they should be the ones sitting here instead of me, except they're both gone.
Yeah, that's, I know just heard a little bit about that, but I'm anxious to hear what you have to say about that.
Well, they were friends in high school. They're both musicians, and both parents were well-known musicians. And they got interested in color photography and began to study it and read about it. They, too, started with an additive process. And additive processes had color fringes. So they weren't going to have 3 or 4 different lenses taking the pictures. They were going to take the pictures through one lens and divide it with a mirror, so there wouldn't be any color fringes. And they put on a big show in New York City about 1917 or 1918. But they were projecting through 2 different lenses, and they projected out of sync and had bad color fringes in there. So they said, no more additive color photography. We're going to work on subtractive color photography.
But they had started as early as
they had
that.
started as the late teens, yes.
I had no idea.
So they were working in their parents' basement in New York City, and R.W. Wood of Johns Hopkins, the physicist, well known, knew Dr. Mies, and he knew them, and he introduced the two to Dr. Mies. And Dr. Mies went down to New York and saw their work, which was very rudimentary. They weren't getting very far, but anyway, he kept in touch with them and decided that the Kodak laboratories, would supply them with materials that they needed. So plate coatings and various chemicals were sent to them from Kodak, at some low price, I'm sure. But finally, they were beginning to make some progress in showing some pictures that looked like maybe they had a technique of making color photography work. Then in the late 20s, Leslie Brooker, an organic chemist in the Kodak research laboratories, who was working on sensitizing dyes to make the silver halide grains sensitive to red, green, and even into the infrared.
So-called panchromatic.
So-called panchromatic. He worked out some sensitizing dyes that could be put in emulsion and that would not wander from one layer to the next. Up till that time, all the sensitizing dyes would wander. So you couldn't really coat a red sensitive, a green sensitive, and then an unsensitized blue sensitive on top of each other and have them keep their sensitivities separate because the sensitizers would wander. But he worked out sensitizing dyes that would stay put. And as soon as this happened, Dr. Mies, who was really a very intelligent guy, realized, okay, color photography can be made to work using the multi-layer system now. And he invited Manis and Godowsky to come to Rochester to work in the Kodak research laboratories. So they came in 1930 to Rochester and went to work. Now, of course, they had much of the research laboratory available to them and what could be done in the plant available to them. They asked for coatings made in the plant of 2 or 3 layers of emulsion, and the plant would say, we can't make them that sort of thing. Well, they'd insist, and the plant would try, and they would make multi-layer coatings. They were musicians. They were talented. They worked in the dark room, and they timed their experiments by whistling or humming classical music. I mean, they knew the timing of the classical music, and they timed their experiments by whistling classical music. Now, that's a true story. I've heard them. I've heard them.
That's an amazing story of that's a new method of precise determination of timeline.
Yes, it is. Yes, it is. A lot of the people in the laboratory spoke of those musicians because they did practice their music, and they went they gave symphonies, and they took part in the musical parts of the city. But in the laboratory, they were imaginative. They weren't really strong scientists, but they were imaginative and darn good experimenters and persistent. They tell the story that about 1932 or 33, when the Depression was really getting bad, and people were being laid off, and certainly there was no expansion in research, and business was bad, they were afraid that maybe they were going to be let go. So they sat down and wrote out. Now, as I said, in the Depression, people were being let go. Manis and Godofsky were afraid that that they weren't going to be kept in the research laboratory. So they decided to sit down and write out every step of a color process that they knew for certain how to make work.
Oh, yeah.
And so they wrote down all of these steps and began to put them together and see if they could come out with a color process.
Oh, yeah.
And sure enough, they did. It was very complicated, and only a couple of musicians would have come out with something this complicated, I think. But it worked. And they made two-color pictures that really were quite exciting. Well, Dr. Mies looked at them and said, well, we'll go on the market with this. And they said, no, let's go now for the three-color process. And he said, no, we'll go on the market with this. So the company started toward the market with the two-color process. But
I had never heard of that.
But they scurried around and put together the three-color process and made it work. And they did that fast enough so that the two-color process never went on the market. And the three-color process did. In 1935, Kodachrome 16mm film was put on the market. Now the process it had something like 28 to 30 steps, all of them critical in timing and temperature control. It took 2.5 hours. It was a very complicated process. Their major contribution, the one part of it that they contributed that wasn't an idea from a lot of other people, was a depth bleach. That was the way you would get the colors in the right layer and in only one layer. The sensitizing dyes in each layer stayed there. That was all right. The coupling developers, which Fisher had invented back in 1912, they used, and the dyes didn't wander, but the couplers did, but they worked that out. Now, the way they worked it out was they developed the cyan color in all three layers first. After developing the negative image.
Yeah.
Then the rest of the silver halide, they developed the cyan color in all three layers. And then they dry the film. And then they had a differential depth bleach that would start bleaching slowly from the top. And they could control exactly where it stopped bleaching by a stop bath. And that was the secret. That was their invention that made this possible. So they would bleach out the top two layers, bleach the dye out, and convert the silver back to silver halide, and then wash that out. Okay, then they developed the top two layers to magenta dye and dry the film. And then a slowly penetrating depth bleach would bleach out the magenta dye from the top, convert that silver halide, that silver back to silver halide, wash that out, and then develop that to yellow. And that was the way they got the cyan in one layer, the magenta in the next layer, and the yellow in the next layer.
But I think almost anybody would know you can't, you certainly can't control the diffusion of anything to a thousandth or a 10,000th of an inch.
Exactly, you certainly would.
Anybody
That's right.
who knows anything would know better than to try that.
Exactly, but that's what happened, and it worked.
Remarkable.
It was remarkable. So in 1935, Kodachrome 16 millimeter film was put on the market. Now at that time, Dr. Mies, who was head of the research laboratory, made a bet with Mr. Lovejoy, who was the chairman of the company, that within 5 years the color film would be outselling the black and white film. 3 years later, Mr. Lovejoy paid off that bet because within 3 years, color film had taken over from the black and white. That just showed that color, that everybody was ready for color when it was ready.
Yes, well, I can still remember the first color movie film that I saw, which happened to be one of someone had taken on an expedition to the South Seas, and every place that was shown, I think it was 16 millimeter, the place was sold out.
Absolutely, absolutely, yes. Well, this was the birth of modern day color photography. Up till then, there had been some tries and there were some commercial applications, but this was really the birth of modern day color photography. And as of now, practically all of the color processes in use by all manufacturers and by all people is based on this color development reaction, different aspects of it. But this type of chemistry is used now in practically all color photography.
There have been really no big fundamental change.
There have been no fundamental change. 2 or 3 changes have made all the difference in the world in quality and so forth, but they really aren't that fundamental. That's one of the things that interests me about an invention. I mean, an invention may be a little improvement on something, but from a usefulness point of view, that may be tremendous. And an invention may be a completely new thought, but when you get through with it, it has no application and doesn't make any difference.
That's right. That's very, very true. And it's a concept that sometimes is very difficult to get across. Some scientific triumphs, at least in the period of time for 10 to 20 years, might have no difference.
Make no difference. And yet the idea and the thought leading up to it is just as big a jump as anything else.
That's right.
Yeah. Well, anyway, this is when I came into the picture. That film was on the market, and I was asked to come and work on 35 millimeter, the 135 for the Leica and Retina cameras for amateur slides. So I entered that program in 1936. When I went into that, I was asked to also, sort of as a sideline, to write a series of articles on the history of the science of photography, which fortunately forced me to study all of the literature in the science of photography, which I hadn't done before, and that was a good thing. Somebody asked me to do that, and I did it, and it really was a very important thing because it forced me to learn what was known about photography. So I became interested in the science and worked in the science of it as well as the practice of the color photography. So we went to work to apply this complicated process to 35 millimeter for the amateur. And that took a lot of detailed doing, but no major changes were made. We also, the group that I was in, had the responsibility of looking ahead and planning to adapt this process to the motion picture industry. Now, Technicolor had a patent on multi-layer films. Mr. Troland of Technicolor in 1917 or 18 applied for a patent on multi-layer sensitivities, and that patent was granted in 1931. So it stayed in force till 1948. Oh, yeah. Now, Kodak, of course, had to have a license under that patent, and we could not manufacture and sell color motion picture film using that patent to anybody.
Oh, yeah.
But we went right to work on trying to apply the Kodachrome process to the motion picture industry through Technicolor and eventually to others. So that was our job. Now, part of that job, part of the use of color film in the motion picture field is you have a camera negative, you take the picture, or a camera film, you take the picture. You make hundreds of prints to go around into the theaters. And you have to have some intermediate stages to put in dissolves and fades and embellishments and that sort of thing. So you have to make copy after copy after copy. And making a copy of Kodachrome to another Kodachrome, you don't get such a good picture. Now, a Kodachrome slide is a beautiful picture, but you make a copy of it, and that's not quite so good. You make a copy of that, and that's pretty poor. So one of my objectives right from the beginning was to learn, how do you make copies of color pictures? And I thought that, I worked that for 5 or 6 years, and I'll come to that later on. But as we were working out the amateur film, we were also working on applying it to motion picture professional and working on different techniques of making copies. And everything we could think of, we would try. As we went to market with Kodachrome 35mm film for slides, we had production charts on the wall. And we had them listed as the Leica program. Now, the Leica was an important 35mm camera at the time. In fact, 35mm amateur cameras were relatively new at that time. Most amateur photography was with big roll film cameras, and the 35mm camera had just come into use. Well, we had listed on the board the Leica program. Well, some management people came down and saw that, changed it to the Retina program, which is the Kodak 35mm camera. That's just a little aside that was amusing there.
Yeah.
But okay, so we got the 35mm on the market and immediately began to try to improve things. The research was never cut back. Research in the color photography was always increased. I mean, we knew that color was wanted across the board, so as we can learn to do it, we'll do it. But first of all, we had to simplify the process. I mean, that process with 30 steps, 2.5 hours was just too complicated. And a couple of inventions were made so that the process was simplified a great deal by 1938. Instead of having the depth penetrating bleach, it was found possible that after you developed the film to a negative, you could expose with red light the residual emulsion that was left, and you expose only the red sensitive layer. Then you could develop that in the cyan color developer. Then you could expose with blue light and expose only the blue sensitive layer, because there was a yellow filter layer which kept the blue light from getting into the middle, and develop that with the yellow developer, and then fog or expose with green light or whatever the middle layer, develop that with magenta, so that you had the 3 color developers that you did by exposure and not the depth bleach. And it was a much simpler process. There weren't nearly so many steps, and it was much easier to control. So the process was converted to that method in 1938. Now, there have been a number of minor changes in timing, and it's cut down to 18 minutes. The temperature's been raised, and a lot of things have been improved since then. But basically, the process is the same now as it was in 1938.
Well, that's a wonderful explanation of these very fundamental developments, which have lasted essentially.
They've lasted till this day. Mm-hmm. Now, we immediately set out to apply this process to sheet film for commercial use. And we went up to, I guess, 14 by 17 sheets was the biggest that we did. But we were successful in developing a type of machine that would operate this process and adapting the Kodachrome process to commercial use. And Kodachrome sheet film was very important in the commercial field, in the advertising field, for a number of years. Just as that was beginning, Bradford Washburn, who was, let's see, what was he? He was in charge of the Harvard School of Geographic Exploration and later became the head of the Boston Museum of Science. He was a photographer, and he wanted to take a lot of pictures of Mount Everest and all over Alaska, and not Everest. I mean McKinley. Sorry.
Yeah.
Yes, and all through Alaska. So one of the members of the research laboratory at Rochester got him some Kodachrome sheet film, and he took a lot of pictures. Now he was told, now this is color film. You don't use a filter. You know, that's because that's just for black and white film for effects. The color film, you don't use a filter. Well, actually, he was using film that was balanced for artificial light, and he was taking it in daylight. He should have been using a filter, actually.
Yeah. Oh, yeah.
So the film came back to us for processing, and here, the first batch of it processed, it was obvious what had happened. So I was given the job of completely working out a new process to try to get that improperly exposed film to come out looking right. And I spent weeks working on the process for that, but got one that did the job all right. So we got some excellent aerial shots that Bradford had taken on the wrong kind of film.
Oh, yeah.
But that was just a little...
I think all of us have sometimes put daylight film or artificial film and then made a mistake, forgotten.
Yeah, absolutely. Yeah.
You know what the effect is.
Absolutely, yes. Mm-hmm. Well, it was possible to work out a special process to handle that, and so that was done. We immediately set out to adapt the Kodachrome process to roll film. Now, roll film was the standard film that all amateurs used, and all amateurs wanted prints. I mean, Kodachrome to this point only made slides, so we set out to adapt it to roll film and to paper, and to make prints from the roll film to the paper. Now, here again, the problem of making a print from a Kodachrome was with us, and techniques called masking had been worked out that helped. I'm not going to go into all of the details of how masking works, but anyway, a mask, a negative image in contact with a positive image when you print it, you can devise a mask that will give an improved quality. So
I believe commercial people in printing use
commercial people in printing used to use masks all the time. Yes, and I don't mean mask around the edge of the picture. No. You know, a negative image over a positive image. Yeah. Yes. Well, we devised a method of adding a mask to the Kodachrome roll film, a silver image mask, and that added about 15 steps to the process. It put it back about as complicated as it had been to start with, but it worked almost, and the quality of the pictures was improved by it. Another problem, the Kodachrome coated on paper gave model. You see, the Kodachrome is a reversal process. You use everything that's there. You develop the negative and dissolve it away, and then you use all that's left of the emulsion to make the picture. And paper has little irregularities, and so there was model. For 2 years, we worked on that problem. And I used to go to meetings in the plant where they made paper and they made the coatings. And every 2 weeks, we'd have a meeting and somebody would report that model had been improved. After 2 years, the model was essentially the same that it was to start with.
One of these intractable problems.
One of those intractable problems. But I went back and reviewed all of the minutes of the meetings later on, and every meeting it was reported improved, but it hadn't changed a darn bit. Well, anyway, it probably was barely acceptable, and we were all ready to go on the market with this very complicated roll film process and this paper with model when the Kodacolor process came along. And I guess I say we were sort of saved from ourselves. Now, let me tell you about the Kodacolor process. As I have said, Kodachrome, you go through the 3 color developers, and each one of them puts one color in. Earlier, couplers had been invented which you could put the coupler itself in the emulsion, and it would stay in that layer. And so you could put a cyan-forming coupler in the red-sensitive layer, and a magenta-forming coupler in the green-sensitive layer, and a yellow-forming coupler in the blue-sensitive layer. Now, making such couplers was complicated chemistry, and designing them was sort of complicated. Kodak had been trying to design such couplers. In fact, people had been trying to design them since Fischer back in 1912. In the middle 30s, Willmans at AGFA in Germany did design such couplers. And AGFA came out with a color negative process, not a reversal process that made the positive, in the late 1930s. Well, about the same time, Kodak was working on couplers that you could put in the emulsion, and Willem and Jelly, a couple of people in the research laboratory, came out with the idea you could make a coupler with a ballast, big molecule on it, which you could dissolve in an oil, disperse the oil in the gelatin emulsion, and that the coupler would react, the developer would go into that oil and react to form the dye. And sure enough, that worked. The couplers that AGFA had worked out had a big ballast too, and but they also had a solubilizing group, so that it would dissolve right in the emulsion rather than being put into an oil. That turned out to be a surfactant. I mean, just by nature, that was a surfactant and made those things very difficult to manage. So in the long run, by chance, the protected coupler process dissolved in the oil has proved to be the process that all of the companies use. It's just one of those things that worked out that way.
Oh, yeah.
But anyway, that was invented, worked out about 1939 or 1940. And just before we were ready to go in the market with Kodachrome roll film and paper, this process came along. And so the whole program that I'd been working on night and day for 2 years was scratched.
Oh, yeah.
And other people had been working on the Kodacolor. So that moved along very fast, and Kodacolor roll film was put on the market in 1941. In the meantime, I went back to working on Kodachrome. I was at that time mostly a Kodachrome person, not Kodacolor. And I went back to working on Kodachrome for application in the motion picture industry. And though we couldn't sell it generally, we could sell it to Technicolor. And so we worked out a Kodachrome process that film with the characteristics properly adapted to the motion picture use. And Technicolor began to use that film in 1942, I think, and used it for a little while and made a few pictures with it. We also decided to begin to make prints from the Kodachrome slides. Now, by now, Kodachrome slides had gotten to be pretty popular. There were a lot of them out there. So we worked out, instead of a Kodachrome process on paper, we worked out a Kodachrome process on white pigmented support, which was smooth, and you could use the reversal process without the model. So we put on the market there in the research laboratory the mini-color prints, which were made from Kodachrome slides. And we did the production of mini-color prints for many years. That process had some unique features. It took a little bit of doing to work out a process of that sort, but it was no big change in procedure or in science. But all of this time, the problem of making prints and making the quality with masking or without masking was in my mind, and everything that came to mind was being tried. And finally, in 1943, lying in bed, I thought of an idea. Supposing that coupler, and this applied to Kodacolor, not to Kodachrome, supposing that coupler, like the cyan coupler, which is going to be formed, that's going to form a cyan dye. Now, supposing that coupler itself is colored yellow or orange, when the cyan is formed, the yellow or orange will be destroyed. And so you'll have a cyan negative image and a yellow or orange positive image. And that orange, I will call it, will just cancel out the undesired blue and green absorption of the cyan dye. And so you will have essentially a perfect cyan dye. Now the magenta dyes absorb some blue and are actually reddish rather than pure magenta. So that magenta coupler is going to be yellow, and the yellow positive will just cancel the blue absorption of that magenta dye, so that you essentially have a perfect magenta dye. Now already yellow dyes don't absorb green and red, so essentially the yellow is perfect. So with colored couplers of this sort, you could make a copy that would be exactly like the original, or exactly a positive from a negative, but still wouldn't have any of the color defects caused by the improper dyes. So,
yes, well, that's a remarkable improvement.
Lying in bed, I thought of that.
That's a very amazing sort of flash that you had.
It was a flash. I'd been working on the problem and thinking about it for years and reading all I could about it, but that idea came lying in bed one night. I immediately went in the next morning and wrote a half-a-page invention report and went to one of the fellows, Vinham, who had helped invent the Kodak process, and I explained the idea. He says, you know, I think I've got a coupler on the shelf here. It's already yellow. Maybe this will work that way. And we tried it, and the very first try, it worked sort of. So we could see that the idea was working. And so immediately several of us got excited about it and began to follow up and try to make that work. 1 month later, I joined the Manhattan Project and left color photography for a couple of years. Right at that point when I'd had that idea, I left for 2 years. Let's break now. I think I'll sort of enter a diversion and talk a little bit about the development of the science, the basic science of photography, the light sensitivity and the development process. The photography is based on using a material which reacts to light, but that reaction has to be magnified a great deal. The development process in the photographic process amplifies the effect of exposure by millions of times. Now, a lot of materials are sensitive to light, but there are not many, in fact, maybe none, that can react to such a small quantity of light as silver halide and have that small quantity magnified such a large amount. Now, many materials have been investigated, polymers and all sorts of chemicals, but it turns out that silver halide is unique. And this has been learned as we go along, and people are still learning about it. But way back, people everything was empirical. I mean, making the silver halide grains, people tried things. They would find that some were more sensitive than the other. Then in the 1920s, Dr. Shepard in the Kodak Research Laboratories began to study gelatin and its effect on the grains that were made. And it was found out that gelatin has some sulfur compounds in it, that cows eat mustard in the fields, and that puts some sulfur compounds. And these sulfur compounds sensitize the silver halide grains and make them much more sensitive than they would be otherwise. They also can go too far and fog the silver halide grains. And that was one of the problems that George Eastman had back in 1882 or 3, when his plates were going bad, it was a bad batch of gelatin. It was in the 1920s that became understood, the role of gelatin and the role of sulfur in sensitizing the silver halide emulsion.
Because that poses a real problem in control by being dependent on how much your cows eat the mustard.
Exactly. It was a long time before it was possible to thoroughly purify the gelatin and eliminate those things, and then add the amount of sulfur compounds that you want to add. Of course, that's the way it's done now, but that's only a relatively recent development that has happened. Then in the 1930s, people began to study the mechanism of the formation of the latent image. I mean, Webb at Kodak, Gurney Mott in Bristol, England, later John Mitchell, also in England, who moved to the University of Virginia, studied the mechanism of the formation of the latent image and how one or two photons could make a stable speck, and the mechanism of silver ions moving through the crystal and then trapping electrons, and then that sort of making a speck that the next silver ion released by light would move to the same speck. That sort of understanding of the electronic nature of the silver halide crystal and its behavior began to clarify the process and made it possible by scientific means to work out means of improving the speed and making those specks more stable, making them more sensitive to the development. Now, the mechanism of how the developer could act on that speck, I mean, the developing agent has to be a reducing agent that will reduce the whole silver halide grain eventually, but making it reduce just the exposed grains with a very small speck and not the other ones is part of the, for a while, was entirely empirical, but through the 30s and 40s, those things began to be studied very quantitatively, so that as of now, speeds of the emulsion are in the thousands when they were in the ones and twos back in those days. So all of those things are a very important part of the development of color photography or any other photography. And many research laboratories, AGFA, the Japanese, have made important contributions. But the Kodak Research Laboratory was sort of the center of the development of this science for many years. In 1936, a member of the AGFA research laboratories discovered gold sensitizing. I mean, you can sensitize emulsions with gold. That increases the little speck of gold. That increases the sensitivity by a factor of 2 or 3 times, which is very important. I can remember in the late 1930s when AGFA came out with a motion picture film. This was black and white, which was faster than the Kodak film. You could always make faster films by having bigger grains and making it grainy. So speed grain is the factor that's important. They came out with a film that was less grainy than the Kodak film and faster. Now there was pandemonium in the Kodak Research Laboratory. I mean, everybody involved nearly had to go to work on what was it that they were doing and how can we do as well or better. And within a short time, gold sensitizing was discovered independently in the Kodak Research Laboratory and used. Now, AGFA did not patent it, so that Kodak...
They tried to keep it a secret.
They tried to keep it a secret, and Kodak later did patent it. Now, there were variations that were patented.
Oh, sure.
Yeah. But Kodak did patent it. But there was an awful lot of scurrying around in those days to learn how to synthesize emulsions that way. Now, there have been a few other major contributions to emulsion technology that give speed grain increases, so that, as I say, the speed has increased many times since 1930. But that was an interesting activity. Now, another part of the speed of the emulsion is spectrosensitizing. I mean, organic dyes are adsorbed to the grains to make them sensitive to green and red and even out in infrared. Now, the mechanism of the transfer of that energy from that's absorbed by the dye into the grain has been a very important study and is a fascinating study. I mean, many dyes will not transfer that energy. In fact, many dyes are desensitizing dyes. You put them in there and they desensitize. But learning how to make one photon of absorbed energy from a dye transfer and give one atom of silver in the grain took a lot of doing. And again, that study goes on in all of the research laboratories in photography. Well, let's get back to sort of the chronology of the development of the various
that
films.
certainly clarifies a good deal the history of the development of the science and technology of photography.
We were about 1941 or 2. No, we were up to 43 when I left.
Up to
Yeah,
43.
yeah, that's right. When I left. Well, during the war, the Kodacolor process, which had gone on the market as roll film, was adapted for use in aerial photography. Now, people in the Army had come to Dr. Mies at Kodak and says, we have got to have Kodachrome for aerial photography. You've got to teach us how to process it in a truck. And Dr. Mies says, there's absolutely no way that you can do Kodachrome that way. He says, we've got this other process. We'll have to go to work real fast and work out a film using that process. And so Kodacolor Aero, later called Ektachrome Aero, was worked out and was used during the war.
For aerial
reconnaissance, yes. Mm-hmm. And also, as part of that use, infrared sensitive film was worked out too. That gives false color. If one of the three colors is infrared sensitive, then you get quite distorted colors, but that becomes a camouflage detection film.
Oh, yeah.
And was used for camouflage detection.
Oh, yeah.
Fairly successfully.
Yeah.
Well, when I got back to Rochester in 1945, the Kodacolor Aero film was in use and had been developed. Ektachrome film, which was that same process being applied to professional use, sheet film Ektachrome, was just about ready to go on the market. The colored couplers, which I had thought of just before leaving, had been worked out and were just about ready to go in a product on the market. A lot of work had gone on there, designing the couplers themselves, having them have exactly the right color. I mean, I talked about the cyan coupler being yellow or orange. Well, it had to be exactly the right tinge of orangeness, and it had to have the right intensity. If it were too orange, it wouldn't exactly match what we wanted it to match. So all of those things had to be worked out. The reactivity of the couplers with the developers, all of those things had to be worked out too. But they had been worked out, a lot of work had gone on, and it was just about ready to go on the market. Well, I was very pleased with that, naturally. One other thing that had happened too, Kodachrome, color developers are toxic or allergenic. I mean, if you get color developers on you, the ones that were classically known, you get a skin rash. And Dr. Mies had decided there's no way we will sell for anybody else to use the Kodachrome process or any process using those developers. We've got to have a non-toxic developer even for the military. So a chemist, Arnold Weisberger, had been working on making developers, and he invented or worked out the formula for a new color developer which was non-allergenic. And so just about the time that I got back to Kodak, that was being worked into the system, and in fact it had been used in the aero film. I mean, the Army use was the non-toxic developer. But let me talk about Arnold Weisberger a minute, because he's a well-known chemist who came to Kodak in 1936. He was from Germany and left Germany to go to England in the early 30s as a result of Hitler. And he became one of the well-known chemists in the world. He wrote books and edited many books. But he came to Kodak and began to work on compounds for color photography. So I met him in the middle 30s. And he remembers this story, which I should have told a little earlier. But I don't remember this story. But he was making magenta couplers for us when we were working out the Kodachrome process for 35 millimeter film. And the magenta coupler was a brown, powdery stuff, a very impure chemical. And he brought us over a sample of nice yellow, clean crystals. He had really made a batch of that coupler that was pure, just as pure as can be. And we tried it. And he tells a story that he came over to find out what the result was. And so I said, Arnold says, now you sit down right here. And I showed him the result. And we got about 80% as much dye with the pure compound as we had gotten with it, as we always got with the impure compound. And we found reasons for that. Yeah. But that set back the purity of compounds for a long time.
Oh, yeah. That's amazing how some of these things work just the opposite.
Just the opposite, yes.
Yeah.
Mm-hmm. Well, of course, by the time the compounds were put in the emulsion, not in the developer, they had to be very, very pure. So the purity of compound did become very important. Yeah. But that set it back for the Kodachrome process for quite a while. Yes. Gee, where was I? Hey, well, as I said, the colored couplers had been worked out and were in a film just about ready to go on the market in 1946. And, in fact, in 1947, Ectacolor sheet film went on the market. That was a professional film using the colored couplers. The first film using colored couplers. It used the non-toxic developer. It was for use by professionals, and they were to make prints using the dye transfer process. A pan matrix film, a matrix film which you could expose with red, green, and blue light through the color negative, the Ectacolor negative, then make a dye transfer print. So commercial photography now had been simplified, and prints could be made by professionals. At this time, we were still looking for applications, looking for new science. I and my boss, Mr. Ralph Evans, were very much interested in the science of color and applying that to color photography. We studied colorimetry. We decided to write a book on the principles of color photography, which we did, in fact, and was published in 1951 or 2, and began to work out all the theories that we could. Actually, I went to a Photokina meeting of the International Photographic Society. I guess this was in the 1950s, and gave a paper on the theory of color photography. As a matter of fact, it was the paper for the entire audience. I had known it was going to be that when I got there, and I was scared to death. I got it for the whole audience as a young man, and gave this paper on the theory of color photography. But that was interesting, keeping all of that theoretical work going along with the practical. We still were trying awful hard to work out a film for motion picture use. And now that the Kodacolor process had been invented, we could use that to make a negative, if that was the right thing. Well, Kodacolor, Ectacolor at the time, was much too grainy, not nearly sharp enough for motion picture use. I mean, all the uses of the film then were big sheets or the roll film several inches wide. And there was just no way that the film was good enough for 35 millimeter, but we kept trying. And we learned how to coat the film thinner and thinner and thinner. Now, that was all done in the manufacturing divisions, but well, not all of it. But anyway, they were learning all the time how to coat thinner and thinner, and that made sharper pictures. The chemists were learning how to make the couplers more soluble, so you didn't have to have so much coupler solvent, trying to make the couplers more active, so we put fewer and fewer chemicals in the coatings. I mean, everything you could do to improve sharpness was being done. Another invention was made about that time. It was discovered that there were sensitizing dyes that not only wouldn't wander from one layer to the next, but wouldn't wander from one grain to the next. If you put them in an emulsion, it would get on the grain, and you could mix another emulsion together, and have a mixed grain process with the green sensitive grains staying green sensitive and the red sensitive grains. So there was a chance to make Kodachrome in 1 or 2 layers. So we put a lot of effort into working out a Kodachrome film in 1 layer. For motion picture use, if that were the release print film, where you make a lot of copies, the cost of that film makes a lot of difference. So we visualized, well, we'll have a color negative film, then we'll print an inter positive from that, both of these with colored compass so that the color will come out all right. And then we'll print that onto this monolayer film. It's a little complicated to process, but professionals like motion picture laboratories could do it, and that will be a cheap motion picture film. So we worked for years on that program. Well, first of all, making the color negative. It wasn't nearly sharp enough. But finally, we had gotten some improvements in sharpness and some improvements in graininess. And we decided, working on roll film for the amateur, and we decided, well, let's make some motion pictures and see what it looks like. So we made some motion pictures cut some of that film up for motion pictures and made motion pictures on it about 1947 or 8. And printed them on a kind of positive film that we were working on. And boy, they were beautiful for just general quality. They weren't very sharp, and they were too grainy. But the general effect was really something. And we showed that to top management, and they said, look, you got to make this work. That's good. We want that. And so we went to work to try to improve the graininess and the sharpness. And I can remember to this day another idea that popped out looking at some pictures over a white view box. An idea as to how to fix the graininess. And it doesn't make sense to people that weren't really steeped in what was going on, but the idea that the cyan layer, instead of coating it in 1 layer, you coat it in 2. And the magenta layer, instead of coating it in 1 layer, you coat it in 2. And you structure those layers right, and that would improve graininess significantly. That was I just knew that would be the case. And we tried it, and boy, it really did. Now, I'm not going to explain why that works, but anyway, it did. And it really worked. It upset everything else. It took a lot of doing to really get that worked out so you could make nice pictures with it. But it worked, and there we had a motion picture negative film. So the company decided, well, we'll sell that motion picture negative. And we've got a positive we can sell. Too expensive. We were still working on monolayer for the positive. Too expensive, but we'll sell this positive. This was about 1950, 51 now. And we don't know how people are going to make intermediates. They'll have to figure that out, and we'll come along someday and have a films that'll make the intermediates, but we're going to sell these films. And so that was started. Yeah. And the Royal Journey, the Queen of England, was traveling through Canada. And that was the first picture made on this combination of films, the Eastman color negative and the Eastman color print film, with no intermediates. Oh, yeah. No other picture was ever made like that, but that one was, and it was quite successful. We were still working on this monolayer. I mean, that was the way to make motion picture positive. Just had to be. It's the cheapest film we could imagine. And another invention came along which completely negated that. And it's also an unbelievable invention. The multi-layer film has many layers coated on it. You coat a layer and you set it up of gelatin liquid or sort of gooey liquid. You set it up, maybe dry it, then you coat another layer on it and set it up. Maybe or maybe not dry it, but you got to set it up and then coat another one on it. Somebody came up with the idea, okay, let's coat all of these different emulsions at the same time. We'll have ourselves a little hopper. Out of this slit will come one emulsion. Out of this slit will come an emulsion. Out of this slit will come an emulsion. They'll roll right over each other. Just stay separate. Go down on the film base, coat them and dry them, and there you've got the coating. Well, there's no way that's going to work, but it did. And I mean, that would all go all mixed together. You know? they would all mix together. Well, as a matter of fact, they stay just clean as a whistle. They do not mix. In fact, there are coating hoppers, which people call Joe Hopper, coat of many colors. Yeah. But there are 6-layer coating hoppers in use today. Now, of course, making motion picture positive with just one coating operation, you got to make the 3 or 4 emulsions anyway. If you're going to mix them and coat them, you might as well feed them separately and coat them. So that completely negated any need for monolayer, and since it was pretty tough, that program was canceled in a matter of a month. So that's the second big program that I was working on that just got canceled. But they got canceled by something better. They didn't fail, they just got improved upon, and something else displaced them. And a lot of things happen like that. There's something better comes along.
Oh, yeah.
Yeah.
That's a remarkable story.
Yeah, yeah. But so that made it possible to have a motion picture process that was economically feasible. So we did go to work and work out the intermediate films. First of all, we made black and white separation positives. And then we made a duplicate negative. You coat those 3 black and white positives onto another negative, and then you'd print that negative onto the print film. And that was commercially used for 2 or 3 years. And then we learned how to make an intermediate film with good enough characteristics so we could have the color intermediate positive print right back onto itself to make a color intermediate negative, and then print that onto the motion picture film. Now that is the film that is in use today. Many improvements along the way, but that sort of film is in use to this day. Well, all this time we were still trying to improve amateur film, and we introduced the colored couplers into Kodacolor roll film, and just as we were about to get that ready for the market, we had a problem with the government, that Kodak was a monopoly. We could not control the processing of Kodachrome ourselves. We couldn't sell Kodachrome film with the processing price attached to the film. We were the only ones that could process it. And we always looked at it as that processing was part of the manufacturing operation of the picture.
Oh, yeah.
The process was much too complicated for the general public to do, but the Justice Department says you can no longer sell the film with the processing included. So we quick decided, well, we don't really want to disperse Kodachrome processing. Maybe 1 or 2 big people can do it, but let's work out an Ektachrome film, which was a lot easier to process, for 35 millimeter, 135 for slides, that the general public can process. And so we very quick went to work and worked out a 35 millimeter Ektachrome film. Now at that time, even though we had the color negative that was good enough for motion picture, Ektachrome had not been brought to be good enough for 35 millimeter use. Ektachrome was still big sheets or roll film. But applying all of the coating technology and the chemical technology to Ektachrome, it was possible to work out a 35 millimeter slide film with Ektachrome. So in 1955, when the Kodak consent decree was signed, and we gave up, we stopped selling Kodachrome film with the processing charges attached. We made Kodachrome process available to people, but we thought Ektachrome is what they should do, and we also thought that Kodacolor was what was going to grow anyway. So this colored coupler Kodacolor was worked out using the non-toxic developer instead of the toxic developer that had been used, so that it could be processed commercially. So in 1955, with that consent decree, color photography sort of became general. It was processed all over the place. Prints, Kodacolor prints were made all over the place, and motion picture film was available. So by 1955, I think you would say color photography was here. One of the problems was in making prints, and they get exposed to light all the time and to the atmosphere, is that the dyes in color photography are not the most stable things in the world, or weren't at one time. And so dye stability was one of the big problems that was studied, all the way going back to the 1940s, people were beginning to learn about it. But it took a lot of learning and a lot of empirical studies before you knew which direction to take. And one of the stories that the Kodak dye chemists tell that's amusing about dye stability says you don't want to wait 25 years to see if a dye is going to fade in 25 years. You have to have accelerated tests. So how do you define an accelerated test that will give you the right answer? It says, take, for example, the egg. Now, you put the egg in the refrigerator, and it's good for months. It says, you put the egg out in the sun, and in a few weeks, you got a rotten egg. It says, put the egg in an incubator, in 2 or 3 weeks, you got a chicken. I left out, put it in boiling water, and in a couple of minutes you got boiling. You got a hard-boiled egg. Yeah. So, how do you design the test, the rapid test to tell what's going to happen to an egg? Now, the same thing to dyes. I mean, some dyes are oxidized to destroy themselves. Some dyes are reduced. Some of them need moisture for stability. Some of them are destroyed in the presence of moisture. So you got to learn all of these things and work out all of these tests before you can really develop perfectly stable dyes. Now, this work is going on, but as of now, the dyes are almost archivally stable, and color prints are quite stable, and color motion pictures are quite stable.
Well, that's tremendous advance.
Yeah, tremendous advance in the last 30 years.
Early color prints really had difficulty.
Well, the early Kodachrome slides before 1938 are all gone now. I mean, they just faded. Now, the Kodachrome slides made in 1938 from then on, in the dark, are essentially stable. I mean, I have some made in 1940 that just kept in an album, and they're just as good today as they were then. Oh, yeah. Now, in the light, those dyes fade some. Yeah. But a tremendous amount of chemical research has gone on in that study. Something like 30,000, 40,000 couplers have been made studying color and stability. No, that's another point that I haven't.
Tremendous effort.
Tremendous effort. Millions of man-hours of work. But designing a magenta, which is exactly the right type of magenta, there's all sorts of magentas, and thousands of them have been made to get the right dye, exactly the right color. Now, the dye, the coupler, has to be reactive with the developer, and so you have to learn chemically what sort of structure is reactive and what sort of structure isn't. And the chemical research that's gone just into this area is, it's huge. Yeah. Mm-hmm. Okay, well, that sort of brings us up to the point when color photography is here. I mean, it's available to everybody. It isn't that convenient yet. I mean, the speed of the films is not that great, 24 or 16 or something. And and loading a camera is complicated. So we set out to make it simpler. From here on, I think the quality is here generally. Okay, let's make it easy, simple, so that people can use it. Increasing the speed. Now, I've told you a little bit about how you do that. Well, all of that has been applied to photography. Increasing the sharpness by mechanical and chemical methods. That work has gone on. And now, in 1963, the cartridge camera was worked out. I mean, the Instamatic camera, Kodak began to sell that in 1963. Now, that had the cartridge with the film in it, which you can load right in the camera. Now, actually, that is saying that when you take the picture, the cartridge is part of the camera. So the mechanics of seating that film, of having the cartridge itself seat properly in the camera, and the film seat properly in that cartridge, so it's in the proper focal plane. That's a lot more. It takes a lot more doing than people would just stop to think about, just putting the cartridge in the camera. But all of those things had to be done. But also, the design of that system was such that the film speed had to be twice what we'd ever been able to make it before. And that took just a lot of steady work, applying, learning, and using all that was learned, and that was successful. One of the things about the Kodak business techniques at the time that amazes me is that In 1963, that Instamatic camera, the camera with the cartridge, easy loading camera, was put on the market. That camera and film were in warehouses ready to go all over the world. So it was announced and available for marketing all over the world at the same time, and the stock analysts and the advertising people, except the ones that we wanted to, didn't know it was coming. I mean, all of that was kept a secret, and that was amazing.
Fascinating there. That could hold
that
whole development, which was...
and it was put in place with the competition and the advertising people not knowing it was there. Well, now, these days, products are announced about a year before they're out there.
That's right.
By almost everybody.
Yes, everybody tries to buy it, and it's not available.
It's not available. Yeah. Well, that one was really done very well that way. Let's talk a little bit about the overall applications of photography. Of course, the major thing is the pictorial application, of course.
Yeah, but right. You mentioned before about the fantastic contribution it made to the application X-ray.
Yeah. Well, X-ray, as early as 1896, film was applied to X-ray. 1928, Kodak, recording checks and recording other objects and documents. But that started in 1928. Now, the characteristics of a film for that use are very different from the characteristics of a film for pictorial use. So a Kodak film was worked out in 1928. 1929, sound on film. Now, sound is recorded in waves or in dots, and the characteristics of a film for that are different from any other. But sound film was worked out in 1929. Kodalith film for graphic arts, for making halftone screens. I mean, that film has exceedingly high contrast and no toe, no gradation down here. It's just almost straight being down to white.
Black or white.
Black or white. That film was worked out, and it took a special, very sensitive sort of process to make that happen. It's only in recent years that, in fact, almost recent months, that a very stable, reproducible process can make that sort of a characteristic in a film. But that now is available. Reconnaissance films using infrared. I've mentioned that. The V-mail film during the war, Kodak, the same sort of film for that. Computer output microfilmer. Kodak worked out a very neat method of exposing film using lasers, and the lasers are modulated by a acousto-optic device to print the digits.
Oh yeah.
And so a computer output microfilm with laser exposure with acousto-optic control is on the market now. I was always amused by that. Nuclear track. I mean, nuclear tracks, mesons, all sorts of rays make tracks in photographic emulsions. And let's see, it was Cecil Powell in 1940 discovered the meson in a photographic emulsion, the track in the photographic emulsion. And he got the Nobel Prize in 1950 for that. That was the fact that it was photography had nothing to do with his prize, but it was photography he was using or the photographic emulsion.
Without that characteristic film, it just couldn't be done. Though.
Yeah, that's right. Yeah. Astronomical use. Now that is a special use. The films are exposed for 4 to 6 hours, and there is a lot of haze and background, so the characteristic that has to be put into astronomical films has to be very carefully understood and designed. An interesting concept called detective quantum efficiency is very important in astronomical films. And a study of that characteristic of films and how you maximize that rather than some other characteristic is what you do when you design an astronomical film. Another aspect of it is exposing for 6 hours. Now, photographic film, there is a law called the reciprocity law. Exposure time and intensity are interchangeable. If you double the intensity of the light, you half the time, you got the same overall effect. Well, in fact, it doesn't work that way. There is a reciprocity failure, and the mechanism of it is now known pretty well. But a film that's going to be used for astronomy, where the exposure is 4 hours, has to be designed very differently from a film where you're going to expose it for a thousandth of a second.
Yeah.
So all of those things have to be learned and used. There was a film called Bimat that was had a great future at Kodak, people thought, which was developed easy. All the chemicals were put in a layer, and they were put in contact with the exposed film. They developed it and sort of drew out of there all the excess, and you came away with a negative. Very much like the Polaroid process, which I will talk about in a little while perhaps. But this Bimat film never did develop an application till the lunar orbiter came along. And back in the early 60s, when they were taking pictures of the moon prior to landing on the moon, they put the lunar orbiter up there with Bimat film in it, which could be developed on the spot, and then those images radio down, and so that was used on the lunar orbiter.
That's very interesting.
Yeah. Okay. Gee, where are we?
Well,
Well, along about this time, I got moved out of color photography for a little while. I became the assistant director of research, and the whole color photography activity, well, most of it, was sort of taken out by responsibility, and I was given responsibility for physics and chemistry and all the new things. And I was sort of, even though I'd been working very much on practical things, I was sort of a theoretical person and interested in the new things. And so I got involved in physics and magnetic tape and electronics and chemistry, basic chemistry and that sort of thing. But I kept involved in my involvement in color photography nevertheless. One of the things that I was very excited about for a while turned out to be Super 8 millimeter. Now, 8 millimeter film, which was the major amateur film, is cut from 16 millimeter film. It has perforation holes, big holes that the film is pulled down with as it moves through, and a lot of space between the pictures, and there was a lot of waste on it. And I had worked an awful hard to improve the sharpness of films, and I figured, gee, if we just use more of that space, that would improve the sharpness of the picture a lot more than any change in the film I can imagine. Yeah. And so I began to promote the idea of using little bitsy perforations and smaller intermediate lines and make the picture just as big as you possibly can.
Yeah.
And people said, well, there's no way you're going to change a format at this time. But anyway, we stayed with it, and we finally sold it to management and came out with Super 8 millimeter film, which was a lot sharper and a lot better than any 8 millimeter had been before. And it took a lot of mechanical doing. It was all mechanical, of course, but that did get done anyway.
Yes, well, I can remember how much sharper and more satisfactory.
Oh, it made much sharper pictures. One of the fellows in the laboratory working on the Super 8 was interested in amateur photography and in general, amateur movie photography, and he was just doing all sorts of experiments. And he wanted to, film speed was improving, and we were using higher speed films in 8 millimeter. Now the 8 millimeter lens is a pretty small thing, and if you have a high speed film and you close down the aperture of the lens, you run into diffraction limitation, and you begin to lose sharpness. So he wanted to see if he could improve that, and so he tried to get a shutter in the camera. A movie camera, there's a shutter that goes around and blocks the light when the film is moving. And so he wanted to get a shutter that he could close down and and cut down the exposure by closing the shutter rather than by closing the aperture of the lens so he wouldn't lose the sharpness. Well, he ran into a very strange phenomenon. As he closed the shutter down to a very small angle, so the exposure was very short, he got very jumpy motion. Anything in movement would be so sharp that he would get very jumpy motion.
Oh, yeah.
And that was not good. Well, he immediately began to think the other way. Okay, let's open up the shutter and see what happens. And he opened up the shutter to something like 330 degrees with just a little black. It has to be a very fast turning shutter, but anyway, it could be done. And he got very smooth action. And that also made him think, okay, now that is giving me 2 or 3 times the exposure that I used to get. Maybe I can begin to take pictures without any lights. Now, the lights for motion pictures at that time were a nuisance.
Oh, yeah.
And so he began to think available light. So he got himself a camera with about a 330-degree shutter and got some of the highest speed Kodachrome slit 8 millimeter and began to take pictures. And sure enough, he could take pictures in a room like this, perfectly well exposed. And in a dark, illuminated bar, he'd take pictures and they weren't quite exposed enough. And then he realized a concept called TEMS, T-E-M-S, terminal exposure modulated scene. Now the eye adapts to light, and everything looks about the same brightness till you get down to a certain level. And then at that level, as the light goes down, you notice it. It gets darker and darker and darker. And that level of illumination is about 7-foot candles. From anything under 7-foot candles looks dark to the eye. And that's the way the picture should look. I mean, you don't want to take a picture in a dark bar and have it come out look like it was bright daylight. Or you don't want to take a picture under moonlight and have it come out look like it was broad daylight, which you could do with a long enough exposure. So that terminal exposure modulated scene of 7-foot candles sort of set the speed of the film that was required for available light photography. Now, everybody had always thought available light would take essentially infinite film speed, so nobody had even tried it. But now that film speed was in sight with that sort of a camera and with a very big lens. So he put together a lens of aperture 0.9 and a shutter of 330 degrees. He got some Kodachrome film, 160 speed Kodachrome, slit 8 millimeter, and began to take pictures. And sure enough, he could get excellent pictures in a dark bar. It looked like looked like what you photographed. He couldn't sell the idea to the marketing people, to the camera people, anybody. He was getting all these exciting pictures and nobody would pay any attention. At that time, the chairman of the company, Dr. Albert K. Chapman, was coming down to the research laboratory once a week and spending all morning having review of what was going on. I don't know of any other company or person anywhere in the world like that. But I mean, that doesn't happen. Every week he was down there each morning. One morning every week, getting familiar with what was going on. One day he was down there, and this fella Gorman, who was doing the available light, was projecting something for him, for somebody else. He wasn't part of the show. But Dr. Chapman had heard him talk once or twice about something he was doing. He looked around and says, "Gorman, what are you doing these days?" He says, "Dr. Chapman, I'm glad you asked." He said, "Let me show you this." So he went and got some of his available light films and began to talk about what he had done. Well, from then on, the camera people and the manufacturing people and the marketing people were interested.
That's amazing.
Yep. But Dr. Chapman picked it up, and so others began to cooperate, and the system was worked out and put on the market.
Oh, yeah.
Well, apparently the marketing people never had really quite understood or had never gotten quite enthusiastic about it, because within a couple of months, everything was on back order. That program went much bigger than anybody expected it to, and it was 2 or 3 years before we were making enough film and cameras to fill the need.
Oh, yeah, that's amazing.
Yeah, but that was one guy with his idea, and it ended from work that he was doing heading in exactly the opposite direction.
That's right.
But he followed it right along there. Okay. Now, we've got available light photography. We've got that, the loading camera, the cartridge loading, so it's simple. Now, let's make it really simple. Let's make the camera small enough to put in your pocket and you have it with you all the time. In fact, one of George Eastman's objectives way back in 1900, he used to say, I'm going to make the camera as simple as the pocket pencil. And so that's what we set out to do in the late 1960s. And by 1972, I guess it was, yes, the pocket camera was put on the market. Now, that pocket camera with the little bitsy 16mm film,
Yes.
when we had come out with the Instamatic, the cartridge load 35mm, we had to speed up the film and make it less grainy. When you go to the pocket, we had to speed up the film and make it less grainy. And that really strained the photographic system, but it was done, and in 1972, the pocket camera was put on the market, and it really took off, and it really made photography available to nearly everybody, children and everybody. Okay, I'm sort of going to step aside for a minute and talk about instant photography.
Oh, yeah.
Because back in the 1940s, Edwin Land had developed instant photography, in which you take the picture and in 30 seconds you take it out of the camera and you got the finished picture. And that was highly successful. And he had developed quite a business, and he wanted to do that in color. And in the late 1950s, he came to Kodak with some chemistry that would make instant color pictures. And Kodak and Polaroid worked together on that for several years, and Kodak worked out, perfected the process, and made the Polaroid film, which went on the market in the early 1960s. Well, Kodak wanted to have its own color instant film, and none of Land's patents were available to Kodak, and so in late 1960s, Kodak decided, okay, we'll go to work and we'll work out an instant process that's free of Land patents and go on the market with our own instant film. And a program was set up called PL 976. This was established in 1968, 970, one of those, I'm not sure. But PL 976 meant a project of the research laboratory to go on the market in 1976.
Oh, yeah.
Well, thousands of people worked on that in the plant and in the camera area and in the film and manufacturing and research, in the chemistry, in the physics. And in 1976, the Kodak Instant camera went on the market.
Oh, yeah.
Now, that just shows that if you're really determined and you do what it takes, you can accomplish an awful lot of things.
Yeah, it's sort of like we'll go to the moon.
We'll go to the moon by 1970. That's right, exactly. Yep. Yeah, there are a lot of things like that that can be done if you really set your mind to it. Now, whether or not this was a good thing for Kodak to do and sort of take its emphasis off other things, that's debatable, and people are still debating that. But still, that was a complete success. About this time, I became director of the research laboratories and was not that much personally involved in the work, though I was following it fairly closely anyway. And the